Number 1, a child tosses a baseball up into the air. On its way down, it gets caught in a tree for several seconds before falling back to the ground. So threw the ball up in the air, it starts to come down, gets stuck in a tree here for a little bit, then it falls down to the ground. Select the best description of the range of this function. So when we're talking about the range is the output values that the function takes on. So the y values, or in this case, the height. So we're looking at how high this ball goes and then all the way down to how low it goes. So the range is these values here. And so this says the range includes all numbers from 5 to 12.5. Well, we have more than 5 because it goes all the way down to the ground, which is a height of 0. And then it goes all the way up to this max point here, which they're saying is about 12.5. So definitely has more than just 5. The range includes all integers between 0 and 12.5. So that's getting closer. But integers is just whole numbers. So then we would be seeing dots for outputs. We wouldn't be seeing a full, like, solid line because it would just be at 5, at 6, at 7, at 8, and it wouldn't have the in between. The range includes all numbers from 0 to 8.5. Well, we know it goes higher than that. D says the range includes all numbers from 0 to 12.5. And this is true because you don't have to be at just 5 feet, then jump to 6. You can be in between. So you can be at 5.5 feet or you can be at 9.7 feet. So all numbers from 0 to 12.5. Number 2, to raise money for a trip, members of the high school math club are holding a game night in the gym. They sell tickets for $5 per person. The gym holds a maximum of 250 people. The amount of money raised is a function of the number of tickets sold. So if we wrote a function here, which I think is helpful to think about, it would be $5 times the number of people. Okay, so we'd have $5 times the number of people. That's going to equal the money that they raised. So which statement currently describes the domain of the function? So the domain of the function is the input. It's the numbers that you're putting in, which in this case is the people. And we know that the gym holds a maximum of 250. So that's the top number that we're able to put in. So when it's talking about all numbers less than 250, that's close because we've got the max of 250. But all numbers would mean that we could plug in 2.5 people. Like we could have decimals, and we know that you can't have half of a person. So that's not going to work out. All integers, well, this is saying every integer possible, and we know that it stops at 250. Also, integers include positive and negative whole numbers, and we know we can't have negative people. So that's for sure wrong. Okay, we'll go over the max, and we can't have negatives. All positive integers, that's better. But again, 260 is outside of our range or outside of our domain. We can't plug in more than 250. So this one would be bad. So D kind of puts all of that together. Positive integers less than or equal to 250. Number 3, C gives the cost in dollars of a cafeteria meal plan as a function of the number of meals purchased, N. The function is represented by this equation. Find the value of N such that the cost of the number of meals is 31. So we can take C of N and plug it in right here. So we know C of N is 31, so we'll plug it in. So 31 needs to equal whatever 4 plus 3n is. So we'll solve for n by subtracting 4 from both sides. So we end up with 27 equals 3n. Then to undo that 3, so let me just write it. I'm going to put 3n on the left equals 27. So I'm going to divide by 3, and we'll get n equals 9. So if we plug 9 into that function, the output will be 31. So this is telling us that C of 9 equals 31. And what does that actually mean? It means that when 9 meals are purchased, it costs $31. So 9 meals are purchased for $31. Or the cost of 9 meals is $31, however you want to say it. Number 4, Lynn completes a 5K using a combination of walking and running. Here are 4 graphs that represent 4 possible situations. Each graph shows the distance in meters as a function of time. Match the description with the graph. So A says that Lynn starts out by running. So your running speed is going to be steep, okay, versus walking or slowing down to a jog. So this running is going to be steep, but then slows down to a jog. So then that's going to be less steep because it slows down. So she's going to start out steep, then she's going to be less steep. Then it says after 10 minutes, she stops. And stops is going to be a flat line. Then she runs the rest of the way. So I kind of see 2 places in here where Lynn is stopping. Here and here, right? Those 2 are flatlining. And so A could be either of those graphs. So I'm going to wait to match those up until I find another one to compare it to. Part B says that Lynn starts the race walking and then gradually gets faster and faster. So that means that this isn't going to be a constant slope. Okay, it's not going to be this straight line where it's the same the whole time. She's going to start out slow and then get faster and faster and faster. So that matches graph number 3. So B would go with graph number 3. For part C, it says Lynn jogs at a steady pace. So this is going to be a straight line, a constant rate of change. So that's this graph number 1 where she just goes up and up and up at the same rate of speed. So that's C. And then D has Lynn starting out by walking. So now she's walking and then she's going to run. So this one is going to start out at some steepness. Then it's going to get steeper because she's going slower and then faster. And that's a little bit different than A, where she started out steep and then got less steep because she was running and then walking. So when we compare graph 2 and 4, the ones we have left, graph 2 starts out slower, then gets faster. So this one's going to be like a jog to a run, where this one is starting out fast and then is slowing down. So starting out fast and slowing down was A. Starting out slow and then getting faster was D. Number 5, the graph H shows the height in meters of a rocket T seconds after it was launched. Find H of 0. So that means that your X value is 0. So if my X value is 0, where's my function? And that's right here. So H of 0 is equal to about 15. And that's your, and remember when time is 0, because this is your T value, not your X value, I guess, in this case. So this means your time is 0. So this is the height. So 15 is the height at 0 feet, or sorry, at 0 seconds. So the height at 0 seconds means that it was launched. The rocket was launched at 15 meters. So that was the initial height, or where it was launched from. Describe the domain of this function. So the domain is your input values. So your domain is going to be these values. It's going to be your time in seconds. And we know that time can be represented in decimals. So the domain here is going to be all numbers versus just integers or anything like that. But all numbers between 0 and then approximately whatever this is. It looks like it's a little closer to 5 than 4, so maybe like 4.8. So all numbers between 0 and 4.8. So it could be 3.7, it could be 2.5, it could be 1. Then describe the range, and the range is all the output values. Okay, so the range is going to be where do we see, so where's kind of the top y value? Okay, so that's here. And then where's the bottom y value? So it goes all the way down to 0 here. So this is your range. Okay, all of these numbers. So in this case, and heights again can be decimals. So this one is going to be all numbers. And then between, and we see that it goes all the way down to 0 and goes up to about 35. So all numbers between 0 and 35. Then it asks us to locate where the h of x, or well, this should probably be h of t, where h of t equals 0. So when does your function, or when is your height at 0? So when is your height at 0 is going to be right here. So at about 4.8. And then what does that represent? So that represents how long it takes this rocket to be launched, go up into the air, and then come all the way back down and hit the ground. So 4.8 seconds until the rocket hits the ground. Or 4.8 seconds that the rocket is in flight, okay, or in the air. Number 6, Mai has to decide between 2 cafeteria meal plans. Under Plan A, each meal costs $2.50. Under Plan B, 1 month of meals costs $30. Write an equation for function A that gives the cost in dollars of buying N meals under Plan A. So for Plan A, if we buy N meals, it is $2.50 for every meal we buy. So $2.50 times N. Write an equation for, or write a function for B, which gives the cost in dollars of buying N meals. Now for part B, we're not paying per meal. We're just paying for 1 month. So the cost of N meals on Plan B is just a flat $30. Doesn't matter how many meals you buy, it's just going to cost you $30. Mai estimates that she will buy 15 meals per month. Which meal plan should she choose? So if we plug 15 into the A function, right, she's going to pay $2.50 times 15, the number of meals she buys. So Plan A is going to cost her $2.50 times 15, which is $37.50. In Plan B, we know that no matter how many meals she buys, it's going to cost her $30. So 15 meals costs $30. So which plan should she choose? And that's going to be Plan B because it's cheaper. Number 7, Kieran is playing a video game. He earns 3 stars for each easy level he completes, and he earns 5 stars for each difficult level that he completes. So we've got easy levels and we've got difficult levels, and they're getting different stars for those. He completes more than 20 levels, so he's getting more than 20 levels total, and he's earning 80 or more stars, so 80 or more. Create a system of inequalities that describes the constraints of this situation. Be sure to describe what your variables are. So I'm going to do E for easy and D for difficult. So this will be the number of easy levels and the number of difficult levels that he completes. So the inequality for the first one, so if we're talking about the number of stars he completes or earns, he gets 3 stars per easy level that he completes. So 3 times the number of easy levels. He gets 5 stars for every difficult level he completes. And he needed to earn more. He earned 80 stars or more. So this one goes with the number of stars, right? Because we're talking stars. So he earned 80 or more. So this number needs to be greater than or equal to 80. Then for the more than 20 levels, so this one is just the number of easy levels plus the number of difficult levels needs to be more than 20. So he completed more than 20 levels. So not equal to, just greater than 20. So here's your system of inequalities. So now we're going to graph this system of inequalities. So I'm going to go ahead and graph this second one first. And I'm just going to graph the intercepts. So if I plug in, so for easy levels, if I do 0 difficult levels, so E plus 0 equals 20 or more, right? So I had to do more than 20. So if he only completed easy levels, he'd complete 20. If he only completed difficult levels, he'd be at least 20. And then we can just connect these. Now we know that it can't be equal to 20. It has to be more than that. So this line needs to be a dotted line. So it needs to be higher than that. And I'm just going to shade this at the same time too. So this, we know he needs to be more than this. Okay, so this is going to be my shading. So he needs to be above 20 levels. So anything up here would be a solution to the number of levels that he completed of each one. Then I'm going to graph this equation. Okay, so this top one, doing intercepts again. So if he only completed easy levels, he'd have 3 stars per easy level. So we divide by 3. And so he would need to complete 26.6 repeating levels. So obviously that doesn't make sense. You can't complete a partial level, but we'll plot it nonetheless. So this is 20. There's 5 spaces in between. So this is 22, 24, 26, 28, 30. So he's going to be at 27 approximately if he only completed easy levels. If he only completed difficult levels to get the 80 stars, okay, we would divide by 5. He would need to have completed 16 difficult levels. So then we'll go to just difficult levels. So 10, 12, 14, 16. So there's our 2 intercepts. And so I'll connect these. Now this time he needed to do 80 or more. So we have an equal sign. So this one is a solid line because we can be on that line. That would give us exactly 80 stars. And then we need to be above that. So for this one, remember that just for the orange, we just needed to be above that orange line. Now we're adding in this blue line. So now we need to be above both, okay, or on the blue one. But so then this one is just above this blue. So if we look at, let me get a highlighter here. Why don't I delete these now? So I'm going to delete out these that we talked about first for that solution. And so now we want to be above both of these. So the solution here is going to be above both of these. So above the blue, not just the orange. So anything here is a solution to both. So we can't be in like this little region because that's only above the blue. We can't be in this little region because that's only above the orange. So above both of them. Then part C says identify a point that represents a combination of stars and levels that is a solution. So anything above both lines. You can literally pick anything up here. So I'm going to pick this one. So then I'll go figure out what point this is. So that's 18, 18 is my example. Again, you could pick anything. Like you could pick this one over here. So that's 22, 24, 26, 8 is another one. Okay, there's a bunch of them you could pick, right? Then it says interpret the point 5, 6 in context. Okay, so 5, 6 would mean, so this is the easy levels and this is the difficult levels. So this one tells us that Kieran completed 5 easy levels and 6 difficult levels. Then it asks us to figure out how many stars he got. So that's going to be plugging it into the equation. 3 times the number of easy plus 5 times the number of difficult will give us the stars. So we know in this one that it told us that he got 5 easy levels completed and he got 6 difficult levels completed. So 3 times 5 is 15. 5 times 6 is 30. So he earned 15 stars on the easy levels, 30 stars on the difficult levels for a total of 45 stars.